Okay, we're talking about 4.3 rotations today. Rotation is a transformation in which the figure is turned about a fixed point. Okay, so if you look at my nice little green triangle here, okay, if we have a fixed point that it's going to be rotating around, okay, and we always go counterclockwise. That's really important. Let's write that down. Always goes counterclockwise, CCW, counterclockwise. Okay, so my point I'm turning my figure around it at a fixed point. And if you take a look at it, what do you notice our path is? Good, a circle. You guessed a circle. Wonderful. Now, let's say we take our triangle and move it out a little bit. It still needs to be a fixed distance from our center of rotation. And look at the shape as it turns around my center of rotation. Okay, my path is still a circle, and if you think about the distance from the point to the edge of the triangle, or actually to any point on my triangle, that's going to be the radius of my circle. Okay, let's move on to an example. Alright, so example number 1, we have a triangle, and its points are at 2, 3, 4, 6, and 7, 1. And we're going to rotate this 90 degrees about the origin. Okay, and we actually have a rule for this. Our rule, if we have our regular XY coordinates, you're going to take the two, switch them, which is kind of like what we did for reflecting about the y over x, or sorry, y equals x, except we're going to make the sign of my y opposite. Okay, I know that sounds a little confusing, so let's try an example. If A is at 2, 3, when it undergoes the transformation, the rotation, I'm going to switch the 2 and get 3, 2, and then I have to remember to change the sign on the 3, so now it's going to be negative. Okay, I'm going to do the same thing for B. If it's originally at 4, 6, we're going to switch them and get 6, 4, and then you have to remember to change the sign on the 6. So that's going to become negative 6, 4. The last one, if C is at 7, 1, that means it's going to become negative 1, 7. And then, of course, you graph those. So you go to negative 3, up 2. That's A prime. 4, 6. B prime. Negative 1, 7. Is C prime. And a way you can check yourself to make sure you actually got it right, if you look at your original figure and you actually literally take your paper and you turn it 90 degrees, it should look like the exact same thing as you just graphed. Okay? So here's my original figure. I rotated it 90 degrees, and it actually ended up looking like what I had just graphed. Great. I'll give you a second to write that down. Okay, so that was the rule for 90 degrees. Now we're going to do an example where we're rotating 180 degrees. Alright, so the rule for 180 degree rotation, you have your normal point XY, and when it undergoes your rotation, you're going to end up with just changing the signs. Your X and Y stay in the same places, they just change signs. Okay, so if we look at R, it's originally at 3, 1. Now it's going to become R prime at negative 3, negative 1. we look at S, it's originally at 5, 1. So S prime becomes negative 5, negative 1. T becomes T prime, which is at negative 5. Have to change the sign, so then it becomes a 3. And the last one, U, was originally at 2, negative 1. So U prime is at negative 2, positive 1, because I just changed the signs on them. Okay. I'm just going to graph it to make sure I got it right. Okay. So R prime is at negative 3, negative 1. S prime is negative 5, negative 1. T prime is at negative 5, 3. And U prime is at negative 2, 1. If I connect those together, I can see that my shape is actually rotated 180 degrees about my origin. If you want to check it by actually rotating your whole paper, you can. So you see the quadrants, those are 90 degrees. So I'm going to have to turn it twice to get it to map up with my primes. So I turn it once. That's what it would look like as a 90-degree turn. And I'll turn it twice. That's what it looks like as 180 degrees. And if you notice, that actually looks like my original picture to begin with. Okay. And that's going to help us when we get to rotational symmetry in just a moment. Okay. So just to recap, our rule for 180 degrees is changing the signs. Alright, we're going to try another example. And this time, we're going to do 270 degrees. Yay! I know y'all are so excited. Okay, so 270 degrees. It's kind of like we're combining the rules of 90 degrees and 180. Okay, so we have x, y. And we're going to switch them. And we get yx. And remember, for 90 degrees, we changed the sign on the y. 180, we just changed the sign on both of them. And in this case, we switch them, and we're going to change the sign on the second piece. Okay, so I'm going to write these down. A prime. Oh, I better not write it there, because that's where our shape's going to end up. Okay, A prime. If we switch them and then change the sign, we have 5, 3, change the sign on the second one, so it's going to end up at 5, negative 3. B prime, do the same thing, switch them, you get 3, 5. However, you need to change the sign on this 5. Okay. C prime, it's going to be at 5, 9, and then it's like, uh-oh, got to change the sign on the second one. And D prime is at 7, negative 6. Okay, go ahead and graph it, make sure you did it right. 1, 2, 3, 4, 5, down 3. 3, down 5. 5 down 9, and then 7 down 6. Okay, so again, you can check it by turning your paper to make sure it actually matches up. Okay. We're actually going to try an example where we put a reflection and a rotation in at the same time. Make this a little bigger so you can see it. We're going to graph RS with the endpoints. R is at 1, -3, and S is at 2, -6. And we need its image after the composition. So first we're going to reflect it over the y-axis. Okay, so I'm just going to take these one point at a time. If R is at 1, -3, and it undergoes a reflection over the y-axis, you have to think to yourself, okay, what was the rule again? Well, it stays at the same height, but your x actually changes sign. Okay, so R prime is going to be at -1, -3. Okay. Now we're going to apply the rule for 90 degrees about the origin to R prime. So we have R prime at -1, -3. And it's going to become R double prime. And remember, your rule is you switch your y and your x, and you change the sign of your y. Okay? So switch them, you get -3, -1. You have to change the sign of the 3. So it becomes 3, -1. Okay? So this is the point after the composition of the reflection and the rotation. Okay, let's try for S and make sure we got it right. Okay, so S is at 2, -6. It needs to be a reflection over the y-axis. So we change the sign of the x. So we get -2, -6. And then we're going to take our prime, switch them, change the sign of the x. So S double prime, take these and switch them to get -6, -2. And then you have to remember, oh, we need to change the sign of that 6. Okay, so our 2 points that we'll graph will be 3, -1 and 6, -2. And for time's sake, I'm not going to graph it right now, but if you need to see it, we'll do it in class. Last thing I want to touch on before we end the video is going to be rotational symmetry. Rotational symmetry is when a figure can be mapped onto itself by a rotation of 180 degrees or less about the center of a figure. Okay, so quickly, I'm just going to take my little triangle here, and I'll show you what I mean. Actually, never mind, I can't use that triangle. Okay, so for example, say I have a square, and I want to know if this has rotational symmetry. Okay, well what I can do is I can twist it kind of like I did my grid paper, and this is going to be my starting point. Okay, so whenever that comes back around, I'll know to stop. Okay, so if I twist it, I want to go until it looks the exact same as it did before. Well, if I stop it right here, it does. Okay, so that's one time. If I twist it again, it looks like itself again. So that's 2 times. I'm going to twist it some more. It looks like the same figure 3 times. And then if I twist it again, okay, now it looked like the same figure 4 times. Okay, so it's rotational symmetry. Is an order of 4, and if I take 360 degrees divided by 4, that's going to give me 90 degrees. So its angle of rotation is 90 degrees. Okay. You'll be doing more examples in class to solidify this information. If you have any questions, please make sure you go to tutorials and ask your teachers. Thank you and have a great day.